DeAngelis.
Hello, and welcome to the webinar on why economizers make sense. My name is Darryl DeAngelis. For this presentation, I'd like to focus on packaged rooftop units. The use of economizers and their controls has steadily increased with the growth of the RTU market. RTUs are used in 60% of buildings. Currently, approximately 700,000 RTUs are produced annually for new construction and replacement. Over the years, RTU physical appearances and sizes have changed due to the many DOE energy efficiency program updates. You can see on the screen some current RTUs, and you can see the hood where the economizer would be located. Economizer dampers, meanwhile, have had very few changes over the past 40 years. With an RTU economizer, the supply, return, and relief are usually interconnected into a single assembly. Connecting rods and linkages were known to be a problem 40 years ago when Belimo invented the direct coupled actuator. Although Belimo has revolutionized the actuator attachment to the damper, the economizer industry has lagged behind. As you can see, there are many points of possible failures, such as breakage, slippage, or seizing. An improved damper design uses molded gears to drive the damper and direct couple actuator when possible. However, due to antiquated actuator design, the needed connecting rods and linkages even remain today. Would you rather have the linkage or the direct coupled actuator? Current economizer dampers are undergoing design changes as new codes are requiring dampers to be constructed for tighter and less airflow leakage when closed. There is also a requirement for dampers to be built to last 60,000 open and closed cycles and to be sold with 5-year warranties, both of which are standards that Belimo has introduced to the marketplace. Finally, we'll have more reliable economizer dampers. The economizer control dates back to the 1980s, and it was pretty crude. They consisted of a spring-loaded nylon ribbon that was used to measure humidity, a temperature-sensing element, an electromechanical switch that was used to open the damper for free cooling. The decision was based on the outdoor enthalpy, which is an energy measurement derived from the temperature and the humidity measurements, and compared to the ABCD setting that's on that dial and the setting of that spring. The damper would often be either full open or full closed, full economizing or non-economizing. Over the life of the RTU, these would often fail, wasting or not even saving energy. What's funny is these products were actually produced until 2010. Can you believe it? Maybe it's not so funny with energy efficiency standards the way they are today. In the late 1990s, a replacement for this nylon control became available. It was a solid-state logic control with an electronic enthalpy sensor mounted on the back, and an additional return enthalpy sensor to compare the two. Like the other control, it used a single relay to switch from mechanical cooling within the damper to free cooling open. A separate potentiometer could be added for the outside air damper for ventilation minimum set points, and an additional kit could be purchased to mount to the actuator for damper modulation to a mixed air set point. Later in the 90s, a more advanced economizer logic module entered the marketplace with a minimum position potentiometer built into the control of the actuator. Many economizers previously didn't even have a ventilation minimum position. As I said, they were either open or closed. But today, with energy efficiency buildings, they are tighter than ever. So it's important to get ventilation air into the buildings. It's healthier for the people and provides a better work environment. The control was either floating point tube position or equipped with a modulating damper based on mixed air temperature. It would work with enthalpy of dry bulb. This control is actually very similar to the previous control, except for it had 2 to 10 volt modulating actuators. The problem with these solid-state controls is that a new control was required to add new features. This control, introduced into the marketplace around 2000, had the capability of adding occupancy input. So now through a relay, you could indicate when the building was occupied and when you should ventilate. It also had CO2 sensor input that could be used for demand control ventilation. It also had the ability to set a balance point in the building pressurization to measure the exhaust and to open the exhaust or turn on the exhaust fan when the damper, outside air damper, reached a certain position. This control is still in production, although it's only available to RTU manufacturers. The big problem with all these previous solutions were they were challenging to set up and very difficult to determine the status and or troubleshoot. In order to properly do this, you needed all these items that were shown. You needed resistors, a battery, temperature sensor, voltmeter. This is why Belimo entered the economizer market and invented the zip economizer. With a focus on faster setup and commissioning, the zip has the ability to auto-detect sensors and components attached. It has automatic damper calibration and onboard commissioning test. There is no problem wondering what it's doing because it has abundant of live operating information to view. Not only does it self-diagnose the problem, it also shows onboard suggestions of how to fix the problem. And if we want to add new features, all we have to do is update the firmware or add on a module. Much easier than the earlier devices. Most RTUs are controlled by thermostats. Some are tied to building automation. Regardless, in order for the new economizers to work, they are required to be wired to at least 2 stages of cooling. This is true even if there's only one compressor in the RTU. The first stage will provide economizing, and the second stage allows integrated cooling. I will talk more on this in the upcoming slides. An occupancy output allows the economizer to know when the building has people in it. When the building is occupied, fresh air must be delivered. If there's no occupancy output, the damper may cycle close during occupied periods and not provide enough ventilation to the building occupants. It may also open during unoccupied periods, causing unnecessary hot or cold air entering the RTU. If you can find a thermostat with an alarm input, this can notify the occupants of a problem up on the roof. The zip economizer has an alarm output that will do that for you. This is actually a requirement in the state of California. Mercury thermostats are no longer in production, and they are incompatible with the new economizer controls. If they do exist, they must be changed. However, the new marketplace for intelligent and Wi-Fi programmable thermostats is growing, and there's a lot of options out there. They provide convenience and also enhance energy savings. So it makes sense to provide the customers with better thermostatic controls. Commercial programmable thermostats have been available in the marketplace for more than 30 years, so it's nothing new. And, mercury thermostats were outlawed because of the mercury, primarily. Now, this slide is going to show the typical function of an economizer. So when it's cold outside and the building needs heating, the economizer, while the building is occupied, should remain at the ventilation minimum position. When it's cool outside and the building needs cooling, the RT uses the outside air to condition the space. In this economizing mode, the damper will modulate to maintain 55-degree discharge. As the outside air conditions warm, the damper will continue to modulate until it finally reaches full open. If the damper is at 100% and the outside air position, the space continues to warm, the thermostat will initiate a second call for cooling. The economizer will enable the first stage of mechanical cooling of the refrigeration system. And then if it passes the high limit shutoff point, we will go into mechanical cooling. The air is too warm outside to use for economizing, and it will return the damper back to the minimum ventilation conditions for the occupants. This slide shows the current energy code adoptions throughout the United States. By federal law, all states are supposed to adopt the most recent ASHRAE 90.1 energy standard or something equivalent or greater. The most recent, as approved by the Department of Energy, is 2013, and changes occur every 3 years, which means there's a change coming soon. The states in blue have already adopted the economizer requirement of 54,000 BTUs, meaning that any unit at 54,000 BTUs or greater requires an economizer. That includes split systems as well. In addition, it is required to have integrated economizer control that keeps the damper at 100% open during this mode of operation. States that are in the green, however, have implemented the most recent 2013 standard, and there are a lot more requirements in this standard, and there are requirements to install a monitoring system to monitor the outside air, the supply air, and the return air. It also has requirements for temperature sensors to have an accuracy of plus and minus 2 degrees Fahrenheit. Additionally, the economizer controller shall be capable of providing system status by indicating the following: when is free cooling available, when the economizer is enabled, when the compressor is enabled, when the heating is enabled, the supply air low limit cycle is active, and the current value of each sensor. The FDD system, which the new economizer is required to have, shall show air temperature sensor faults, when the economizer is not economizing when it should be economizing, and when the economizer is not economizing when it should not be. Damper is not modulating, and excess outdoor air. As shown in this slide, you can see the various energy savings throughout the United States. Even in the Deep South, there is energy savings. This is why economizers are being required in every state. There's more recognition of the energy savings and ease of installation and fault detection benefits of adding new economizer controllers to existing RTUs. The ZIP economizer itself is known as an advanced digital economizer control. There are also additional energy savings when you add on other control capabilities such as demand control ventilation and enhanced ventilation control. A combination of all three of these is known as an advanced RTU controller. The Department of Energy has led the advanced RTU campaign for approximately 3 years. There are several utilities throughout the United States that offer rebates on retrofit economizers. Owners and contractors can receive rebates on new RTUs with economizers and retrofitting with advanced RTU controllers as well. What's great about the ZIP economizer, by entering your US zip code or Canadian postal code, the ZIP economizer will automatically recognize your climate zone, and it will set the high limit changeover to maximize your energy savings. You can be ensured that your high limit temperature will meet the current energy code when you set in the zip code. We tried keeping it simple by providing an onboard help in setting up and troubleshooting the economizer. There's a little I button there on the menu screen, and if you push the I button, you get more information. As previously mentioned, the old economizers are difficult to troubleshoot, and you really had to be present to see what the problem was. With up to 10 historic alarms, alarm counters, and timestamps, it's really easy with the ZIP economizer. If you look at the screen now, it shows you some of the benefits of today's economizer. And here are some of the innovations also that the ZIP economizer brings to the market. It makes easy sense to change to a new economizer. Thank you very much for your time today. In just a few moments, Michaela will lead the question and answer portion of this webinar.
Thank you so much, Daryl. So for anyone who joined us maybe after we did our introduction, just want to let you know that this webinar is being recorded. So if you did miss anything, we will send out a link so that you can view it, the presentation in its entirety. So right now we are going to have a question and answer session. So on the right-hand side of your screen, you should have a box that shows questions. That is where you can type in your questions. I will read them aloud and Daryl will answer them. Also, if you're thinking about some of those questions, or while you're thinking about those questions, we do have some handouts in which you can download directly from the GoToWebinar viewer. It's a Zip Economizer pack flyer, Zip Economizer FDD document, and an installation and operation guide. So Daryl, we do have some questions. Are you ready?
Great. Yes.
What about What about OSHPD? Does adding the Zip Economizer controller invalidate the Shake Table Test certification?
That's an excellent question, and I don't have an answer for it. The shake table, I assume you're referring to seismic requirements? I can't say it should not affect the seismic ability because it's designed to attach the RTU. That's what the question was.
Okay. Do we have wiring diagrams?
We certainly do. One of the handouts that are attached are installation and operation manual. And in that you'll see wiring diagrams that are provided for each sensor configuration, whether using single dry bulb, differential dry bulb, differential entropy, etc. And so you find those individually on our website or in that IOM.
Okay. Does this work? Does this also work for the Canadian market by province/territorial using the related postal code as it does for entering a zip code?
Yes, what we did is we used the National Energy Code of Canada. Canada is certainly different than the United States as far as their adoption. They do put a lot more on the provinces. Many of the provinces do follow 90.1 requirements, ASHRAE. So if you don't know, please consult your local code official. With the Zip Economizer, you can always change the high limit set point by going into the settings menu and go into the menu item, the high limit modification.
Okay, next question. Is all the wiring low voltage AC or DC?
Yes, everything is AC, 24 volt AC. Typically, the transformers in the rooftop unit are sized such that they can handle the economizer and actuator load. If you have to add on other devices like power exhaust or CO2 sensors, you're likely to have to add another transformer to power those devices.
Okay. If each damper has its own actuator, can you control all three?
Yes, you can wire 3 actuators in parallel, and the outside air damper actuator used for economizing, you take the feedback of that actuator and bring it back to the Zip Economizer so it knows exactly where the outside air works, and it will work fine.
What are integration options to existing BAS?
Currently, we'll be rolling out later this year. We will be rolling out BACnet. So we plan for that, and we have a communication module with an RJ45 connection currently. So we will be MSTP BACnet in the future.
Does a zip unit work with multiple compressors?
The zip is designed to work with up to 2 compressors. Typically with rooftop equipment, we will see this product used up to 30 tons, so up to 2 15-ton compressors. Some systems have control boards. If there's an onboard DDC that's from the factory, such as Carrier or Train, then it's likely you cannot integrate with the product. Sometimes you can put the zip product before the DDC control, but it all depends. You have to consult the local office for that manufacturer.
Can preset values be overwritten during setup?
One of the things that we did with the Zip Economizer is we didn't install any preset values. Basically, you have to set the product up in order to make the product function. And once you enter the zip code and the minimum position, those are the two minimum items you have to put in. The more products, more components you add, like if you add demand control ventilation, you have to put in some CO2 values. But once you set those things up, it goes through a damper scaling and then it comes live. If you do not put those values in, then it will not operate the rest of the rooftop unit as far as the mechanical cooling is concerned. So that's important. So there are no presets other than the zip code, and you can override what the zip code high limit settings are if you wish to.
Okay, next question. Is this more of a retrofit option versus a new RTU install?
We do have some partners on the OEM side of the business. We sell a lot through the retrofit. There are damper manufacturers that install this for their economizer damper manufacturers. There's one by the name of Cambridgeport. There are other OEMs that use this in their assembly, so yes, it's both.
Okay. Does it work on multi-stage dampers?
Yes, and I just want to add, we also sell through micro if you want to use a micro metal damper. Does it work on multi-stage damper? No, it's not designed to work with multi-stage dampers. It's the same damper for both the ventilation and for the free cooling.
Okay. Does this work strictly with RTUs? What about split units with a rooftop condenser and penthouse louver for intake?
Could you repeat that, Michaela?
Yes. Does this work strictly with RTUs? What about split units with a rooftop condenser and penthouse louver for intake?
Yes, of course. It will work with split systems, again, up to 30 tons typically. So you will have the economizer will control the compressor and the condensing unit. You just have to run the wires, make sure there's not the wires running out there to the condensing unit to pull on the contactor, and the actuator will control the louvers on your penthouse, as in that example, or air handling unit.
Great. Well, that looks like that's it for all the questions, but if you should come up with an additional question or comment, please feel free to email us at marketing@us.belimo.com. Our next webinar will be on April 13th at 1 p.m. Eastern Time, and it is going to be on the new ultrasonic flow meter, the right solution for accurate measurement. Thank you so much, everyone. I hope you have a fabulous Wednesday, and we'll see you at our next webinar.
Thank you very much.